Hello everyone. So let's solve today's LeetCode POTD, count mentions per user. So the problem states that we are given an integer number of users representing the total number of users and an array events of size n cross 3. Now each events of I can be either of the following two types. Either it can be a message event or it will be an offline event. Now what is a message event? So the message event will contain the message, then the timestamp at this message is coming and a mentions string. Now it means this message event denotes that a set of users was mentioned in a message at this particular timestamp. Okay, and the mentioned string can contain means either the tokens of the users or there can be three types. So it can be like ID number means ID1, ID2, ID3 and so on, where number is an integer in the range 0 to number of users minus 1. Okay, so ID 0 till ID n minus 1. Now there can be multiple IDs separated by a single white space and may contain duplicates. So this can mention even the offline users. Okay, so this is the first kind of mention string that we can have. The second kind of mention string that we can have is all. It means we are mentioning all the users that we have on the platform, means all users from 0 till n minus 1. And here means we'll only need to mention the users who are currently online, means we will not be mentioning all those users who are currently offline. And the next event that we have is offline event, where we have offline events at this particular timestamp such that this ID, we are given an ID and this user becomes offline for 60 time units. That means the user becomes offline at this particular timestamp and he will automatically be online again at this particular timestamp, means after 60 units. So he will be online again after timestamp of I plus 60. Now we need to return an array mentions where size of mentions is n, where mentions of I will represent the total number of mentions that each user ID has across all the events that have occurred. So there can be multiple message events, like suppose ID 0, ID 1, then all users are called, then here are called. So out of all message events, we need to tell for each user how many times that particular user has been mentioned. Okay, and now one more thing is given, that all users are initially online, and if a user goes offline or comes back offline, their status is changed before handling any message events that occur in that. That means if at particular time t a message event offline is occurring, okay, message event offline is occurring and as well as a message event is occurring. Okay, so that means this particular user will first become online and then this message event will be processed. Okay, so the status change is processed before handling any message event that occurs at platform. So if a particular user becomes offline or online at a particular timestamp, then that needs to be processed first. Then we'll be seeing whether any message events are happening, like we are mentioning some users or not. Okay, so first the user will become offline or online and then we'll be processing the message events. And we can see like the number of users can go up to 100 as well as the events length can also go up to 100. And each, like the number of mention strings, that this timestamp that we have events of I1, this can go up to 1e5 and the number means ID number will be from 0 till n minus 1. Okay, and in each message event the number of mentions that we can have is 100 only. So this can go up to like 100 approximately, and the number of events that will be occurring is 100 as well as the number of users is also 100. Okay, and it is also guaranteed that a user ID referenced in the online event offline. Okay, so this offline event will only be called for this particular user ID when the particular user is online. Okay, so let's see like some input examples to see what the problem statement is here. So we have the events, we have the number of users as 2. So initially the number of mentions for each of them was 0, 0. Now the first event occurred at message event of at timestamp 10 and ID1 and ID0 was called. That means at timestamp 10, both of these users were mentioned. So both of their mentions will be increased by a count 1. Now at timestamp 11, this user 0 becomes offline. Okay, so means user 0 will become offline, and the time for which he will be becoming offline will be what? 11 plus 60. That means 71. Hence, this user 0 will now become online at this timestamp 71. So now this user is offline till timestamp 71. Now at timestamp 71, we are messaging here, and here means all the users who are currently online. So for here event, what we need to see is, will iterate means for all users from 0 till n minus 1, we'll see like if the current timestamp that we have, if it is greater than equals to, means the time at which this online they will become. So online time of I. So for all users from 0 to L minus 1, we'll check, means what are those users whose online time of I is less than equals to current timestamp. Okay, and that means these all users will be notified. For example, here 71. So at 71, this particular user, 0th user, became online. So first this user will become online, and then it will be like here. So that means it will be mentioning all those online users. Hence this 0 user will also be mentioned. And as we know, initially all users were online. So user 1 will also be mentioned because he did not went offline anytime. So hence both of these mentions count will be increasing by 1, and hence in the end, after processing all the message events, the final mentions array would be 2, 2. Let's see another input. So we are again having two users initially having a mentions count at 0, 0. Now we have a message event at timestamp 10 ID1 ID0. Hence both of these mentions count will become 1, 1. Now time at timestamp 11 ID0 becomes offline. So this user 0 will again become online at what? At timestamp 17. Now we have the message event at timestamp 12 who will be mentioning all the users. So for all the users, what do we need to do? We need to from 0 till n minus 1 increase the mentions count for all users. Okay, so it does not matter whether a user is offline or online, it will be mentioning all the particular users, and hence is here it is all. So mentions count will be increased for both of these values, but this 0th user was still offline only because he was beginning online at 71. But since the message event was all, hence all of the users will be mentioning, and hence both of their mention count is increased by 1. So hence the output here is 2, 2. Let's see another input. So we have the mentions count as 0, 0. Now the event offline occurs. That means at timestamp 10, this 0 user becomes offline. So hence it will become online at what? Timestamp 70. Okay, 70 only. Now for the message event, we have at timestamp 12, we have a here event. That means we will be informing all the online users. So for all users from 0 to L minus 1, we will see like if t is greater than equals to online time of that particular time. So you'll see for 0, the means current time is 12 and online time was 70. So it is greater than equals to is not true. So hence for 0, it will remain 0 only. Now for 1, we have the current time as 12, but online time was, it was initially online only. Okay, so we can make it like -1 or 0. So 12 will be greater than equals to -1 or 0. So hence this will be true. So hence this user will be informed. So first user will be informed, and hence its mention count will be increased by 1. Okay, so hence the final output after processing all the message events will be 0, 1. So as we see, like for all the here events, we need to maintain something which stores like the time at which that particular means each particular user will become online. Okay, the last time at which each particular user will become online. We need to be able to means store these values, so that when we get a here event, for each user we will traverse and see like whether the current timestamp is greater than equals to the timestamp at which that particular user will be becoming online. Okay, since one thing we observe is we need to means store these values online time of I, and how will we storing it? So we'll simply like update it with like current timestamp plus 60. Okay, when this like offline event is called, and when this timestamp occurs, that means we can simply see. And what else we do need to do? So we will like, since we means this is a time series uh, data that we are given, so we definitely need to process the events in a particular time. Okay, in the increasing order of time, and we are not given like events of means I1 and means events of I1 are given in sorted order. It is not given. Hence we need to process all the events in order of increasing time. Hence if we are given the events array and events of I1 is the what is the timestamp. Hence we need to store means process the events on the basis of increasing timestamp. Hence we need to sort it on the basis of this. Okay, on the basis of events of I1. Now what about like, we also need to make sure the condition that the offline event means at a particular, if the timestamp, if events of I comma 1 is same, means at time t we are having a offline event as well as a message event is occurring. So if we are having both of these events at particular time t, then we need to make sure that this event is processed first and then this message event is processed. That means the user becomes offline first and then the user becomes online. Then the message event occurs. That means if like timestamp is same, means t1 equals to t2, then what we need to do, we need to do like offline event should occur first. So the means events of I0 should occur first for the offline event and then for the messaging. Since will be like, need to sort it using custom comparator. So we'll be sorting it on the basis of custom comparator. Now what do we need to next, what do we need to do? We need to store all these online time values for each of the users. So initially what we'll do, we'll create a suppose a vector of int which denotes like free add. Okay, for all users from n, and initially it is 0. Okay, now this free add will store the online time for each user. Okay, it is the same as online time. So the user will become free at that particular time. Now when a offline event is called for particular user I, then what we'll do, we'll simply do free add of I becomes the, if it is at called at current time t, so it will become t plus 60. Okay, and now if we call message here event, then we can simply iterate through all the users and see if the current timestamp that we have is greater than or equals to free add of I. That means the user has become free. In that case only we'll be increasing its count. Okay, for the mentions count, and else like will not be increasing it. And for normal all event we'll be simply increasing all the counts of all the users. And for counts where we are given like id1 then space then id3 space id6 and so on, so in this manner we need to means parse the string with means separated by spaces. So we need to first parse this part, then this part, then this part. So what we can do is we can simply use a string stream to pass this input, and at each string what we'll do, we'll avoid the first two characters. We need to avoid the first two characters and we simply convert the remaining part into a integer. Okay, so we can use string to integer inbuilt function, and then we'll be able to parse this value, and then on the basis of that we'll be able to access the user that we are means account means calling the message event for or the offline event for. Okay, so I hope like how we'll be using string stream. So string stream basically skips for all the spaces, or if there are commas as well, we can specify that we need to skip over the commas and it will help us simply skip over them. Okay, so hence the first string that we'll get will be id1, then it will be id3, then it will be id6. So this is why string stream is used. Or you can like write it in a brute force manner as well, that as soon as we encounter, create a temporary string and keep pushing it back till we encounter a space. As soon as we encounter a space, we'll stop, and then the temporary string will be storing this value. And since then we'll skip the first two characters and convert the remaining characters into an integer and then process it. So we can also do that, or for the clean code we can use string stream as well. So let's see the code as well, because the implementation is pretty simple here. We just first step was to sort it using custom comparator, and the next step was to calculate this free add values for the offline events, and then based on the message events called, we try to update it on different ways. So the first step is sorting. So how it will sorting it? So let's see the custom comparator that we'll be using. So we need to sort the events. So we need a custom comparator. So the first priority is the timestamp. Means the timestamp should be ascending order. Timestamp what? It was a of 1. Means if there are two strings, means we are writing this custom comparator so that we are able to see. So for a and b, we, if a is greater than b, then it will be in decreasing order. If a is less than b, then it will be in increasing order. This is what custom comparator means. So if a comes before b, then it is increasing order. So now the timestamp of a is stored at a of 1 and timestamp of b is stored at b of 1. Okay, so now if both of timestamps are not same, then a means time a should come before time b. Okay, so we return true, means if we, this time a less than time b denotes that if time a is less than time b, then this will become true, and if it becomes true, then they will come in the same order as they are present in these arguments as parameters. Okay, and if this value means is false, we are returning false. That means they will be up, means appearing in the opposite order. That means this b will come first and then this a will come. Okay, so I hope you know how to write a custom comparator. Now comes the scenario where we need to handle offline events before message events. So we need to see, like, if times are equal, offline, that is offline should come before marriage. Okay, so string comparison, like if we like simply try to do string comparison, just like we try to do time a less than time b, then we see that o is less than message and it will become false. Hence if it becomes false, so the second string will come first and then the first string will come. Okay, so it will be the reverse of what we need. So we will explicitly handle this, like if the offline event should come first. So if this event is offline, then we should return true. We will return true so that this a comes first and then b comes. Okay, and if means in any other case, if both are offline, then we can process in any order, like either a or b then a. And if like both of them are message events, then also we'll be able to means b means if so yeah, so if a of 0 is offline, then that means a should come first. If like b of 0 is offline, then we'll simply return false. In that case we'll return false so that this b comes first. Okay, so if it is like message event and then offline, so in that case we'll simply return false so that b comes first and then a comes. Okay, and if both are message events, then this will not be the case. That would have been, means we can return it in any order. So I hope like sorting it, how we are using custom comparator to sort the values on the basis of our requirements is clear now. Now let's see the implementation part of means how we'll be keeping track of the mentions count for each user, and how we'll be incrementing it based on the different types of message events, as well as how we are store the free add time or the last online time, means the time at which each user will come online, how we are keeping track of it. So let's see that. So we create a vector mentions which will be initially 0. With this is what we need to return as the result finally. And we also create a free add vector which will store the time when user becomes online. Okay, now we'll be processing the events. So the type that we have is stored at event 0. Timestamp that we have is we need to convert that particular string to integer. Okay, so we use this inbuilt stoi to convert that to integer, as well as the content that we have, means either it will be ID0, ID1, so on is separated by spaces, or it will be all, or it will be here, okay, or it will be a single ID in the case of offline, okay. So in all these cases we need to means the content here will be these strings. Now if the type is offline, then we need to convert this simple ID into an integer. So we'll in the form of this, when the ID is offline, we are given ID I only, means this is an integer, I think IDI. For example, in the user as well, yeah, it was not given in the form of ID0, it was given directly in the form of integer only. Hence in the offline case, this was not given in this form, this was given like 1 0 n minus 1 till so on, okay. So a single value will be given, so we'll simply convert this string that we have to integer, okay. And now user will be offline starting at timestamp till timestamp plus 60, so then it will be online again at timestamp plus 60. So this is what we updated, we update the free add of for this particular user ID with timestamp plus 60. Now we need to handle the three cases of the message events. So now if the content is all, then what do we need to do? For all users from 0 till n minus 1, we need to increase their mention count, okay. So we simply do that. Else if it is here, then we need to account only those users who are currently online, means the current timestamp that we have should be greater than or equal to the online, means the time at which they became online, okay. So we'll be doing this check and then only increasing mentions count. And else we need to see, like we'll be given it in the form of ID0, ID1, ID4 and so on, right? So we need to use string stream to pass through the means strings, getting rid of the spaces. So we will be using string stream. Now this SS means will this is the content array, content string. Now we this SS means it will be processing each word, means it will be processing words by skipping the spaces, okay. So this SS will be string stream of this particular entire string, and then we have this token. So each of this will be stored in the token. So this SS will initially point to this string, okay. Now we push this in our token. So as soon as we do this, this SS will move till at this point, and the token that we currently have will be storing this string, okay. And then we'll be keep doing this till this SS means is less than till the content size, okay. So we'll be doing this while SS write shift token exists, means we are able to push the values of SS into a token, means there exists some value to push. Now the token will be in the form of this, either it will be this or this or this. So hence we need to process the means the number will start from from second index, okay. So after ID there will be some particular integer which will need to process. Hence we can skip the first two characters ID and pass the rest as an integer on. So the user ID that we'll have is, we simply you again use string to integer function from the substring starting at index 2 till n minus 1. So you can simply write it token dot sub str2, okay. And then we'll need to increase their mention count by 1. We simply do that, and in the end we'll simply return the overall mentions vector to return the total times each user was mentioned. So I hope like this was like pretty simple. We just needed to like the implementations may be difficult, and if you are not aware about string stream, then it might become more messier as well. Means this part might become more messier as well if we try to brute forcefully go through, means iterate through all the spaces. So yeah, this was the approach, and as you can see, like time complexity here would be what? Since we are sorting the events, so the sorting would take big of n login, and n here is 100 only, okay. So 100 into like it will be 6 7 suppose, so it will be big of 700, okay. Then we have this where we are iterating through all the events, so this is big of n. Then for each user, if it is online offline it is good, then again we are iterating through all the users, so big of n. And the number of users, this is same, and for the token as well, at most 100 users we will be calling, so this is also approximately big of n only. So hence the overall approach here for this approach was big of n square, big of n into n plus big of n log. So this will be like the simple approach for this problem. Let's try to submit the code as well and see uh, whether it works or not. So this is the same code that we had. We first, step 1 is to sort the events, and then step 2 is to process those events. So we do the same as we discussed. Let's try to submit it and see how much time it takes to run. Uh, let's submit it again, and it should work now. And as you can see, like it runs in 32 ms, which is pretty fast based on the n square means 1e4 1e5 approach. So this was like the overall this approach and the logic for this problem. This was like I think like just the implementation based concept problem. There was nothing like nothing logic or you need to explicitly think about, and it was simply an implementation based problem. And since the problem statement is so big, you need to means break it down into smaller parts and then read the entire statements, as well as see all the notes here that offline event should be processed before any message event at that particular time. So all of these needs to be studied. So like only the means the size of this problem statement makes it a medium, otherwise it would be like on the easier side only. So yeah, I hope like you are able to follow through the approach, and if you did, make sure to like as well as subscribe. And if you have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.